Mercury, a planet of extremes. It's the smallest, the fastest, and one of the most mysterious worlds in our solar system. But what if we told you that Mercury is more metal than rock? Scientists believe that beneath its cratered surface lies a massive iron core, one so large that it makes up 85% of the planet's radius. But how did Mercury end up this way? And could it have once been a much larger world? Today, we're uncovering Mercury's deepest secret. Let's start with a fact that baffles scientists. Mercury's core is way too big for a planet of its size. While Earth's metallic core makes up about 50% of its radius, Mercury's core extends nearly 85% of the way to the surface. This means that Mercury is mostly metal with only a thin outer layer of rock. So why does Mercury have such a huge core? Scientists have come up with a few theories, but one of the most intriguing is that Mercury wasn't always this small. Billions of years ago, during the chaotic days of the early solar system, planets were still forming and colliding. One theory suggests that Mercury may have once been much larger, with a thick rocky mantle just like Earth or Venus. Then, disaster struck. A massive impact, possibly with an asteroid or even a small protoplanet, may have stripped Mercury of most of its rocky outer layers, leaving behind just the dense metallic core and a thin crust. This would explain why Mercury is so much denser than any other rocky planet in the solar system. If this theory is true, Mercury might have once been twice its current size, only to be reduced to a metal-rich world by a cosmic catastrophe. Despite its massive core, Mercury has another mystery, a surprisingly weak magnetic field. Unlike Earth, whose magnetic field is strong and protects us from solar radiation, Mercury's field is just 1% as powerful. But why? Scientists believe this has to do with how Mercury's core behaves. Earth's core generates a strong magnetic field because of its active, churning molten metal. Mercury's core, however, may be cooling and solidifying faster than expected, weakening its magnetic field over time, and because Mercury orbits so close to the Sun, its weak magnetic field is constantly bombarded by solar winds, squeezing and distorting it into an unusual shape. This leaves Mercury exposed to the Sun's intense radiation, further eroding its surface over time. Even with all we've learned, many questions about Mercury's core remain unanswered. That's where the Bepi-Colombo mission comes in. Launched by the European Space Agency and JAXA, this spacecraft is currently traveling toward Mercury and will begin detailed studies in 2026. Scientists hope it will reveal more about Mercury's core, its composition, and whether the giant impact theory is true. Bepi-Colombo will map Mercury's interior structure, measure its magnetic field, and look for evidence of what really happened to Mercury's missing layers. So what do you think? Did Mercury once have a thicker mantle before a giant impact stripped it away? Or could there be another explanation for its strange structure? Let us know your theories in the comments. Mercury may be small, but it's full of giant mysteries. If you enjoyed this deep dive into Mercury's metallic core, hit that like button, subscribe, and turn on notifications so you don't miss our next episode. And stay tuned for tomorrow's video where we explore the robotic missions that have unlocked Mercury's secrets.